Hi, I'd like to talk to you about directors. And what's meant by directors is we're going to take a benzene ring, C6H6, and a benzene ring has 6 carbons in a row, alternating single and double bonds, with 6 hydrogens on the outsides here. Every carbon here is sp2 hybridized, meaning 120 degrees. You can think of it as like single, double, single. Every carbon's got a single and double bond within the ring. What's going on here, though, is one of the hydrogens has been substituted with a chlorine for this top example. One of the hydrogens has been substituted with a nitro group, NO2 group down here at the bottom. They behave differently. Directors, it's the chlorine, it's the nitro, it's the group that's already present on the ring that's going to direct where the next substitution occurs. So both of these reactions are the same. Both of them are going to involve a substitution of hydrogen with a bromine. We need to add Br2 to the mix. What's going to happen with this one is chlorine is going to be an ortho-para director. Now the positions along the ring, if we put chlorine here at 12 o'clock up at the top, then we're talking about we could replace the hydrogen that's off here, we could replace the hydrogen off here, or we could replace the hydrogen down at the bottom. Now if you're thinking for a moment, but what about the hydrogen here and here, in other words on the left side? Now this hydrogen here is equivalent to this one because the benzene ring is flat. So if you replace here, it's the same as here, it's indistinguishable. This 2 o'clock position is what's known as the ortho, and I'm going to go ahead and abbreviate with O because we'll call our product O for ortho. Now, ortho comes from the ortho meaning next to. This is what's known as the para position, or P, meaning para, across from, or opposite, parallel. And so from chlorine, we have next to, O, we have opposite of P. And there's an intermediate position. And something meaning intermediate or in between is meta. And I'll signal this with a little m. So there are 3 different positions where we can go ahead and do a substitution. Chlorine's going to direct this to either ortho or para. The reaction involves one bromine knocking off a hydrogen on the ring. That hydrogen will leave and hook up with the other bromine that has been left behind from the Br2 molecule. So what's going to happen is, let's pick on ortho first and say the hydrogen here is knocked off and replaced with a bromine. But if we were to have, let's say, gram quantity of this, approximately half would go here, plus half of our para would be formed. So we end up here with a mixture, approximately 50-50 of each of these. And so this is called an ortho-para director. The little molecule that's formed, we're not really concerned about. It's not the organic product, plus HBr. The hydrogen came from the ring. It was replaced with the bromine, and one bromine was left behind. It turns out that nitro, NO2, groups are meta-directors. Experimental evidence shows us, and then the theory talks about electronegativity concerns, whether it's going to withdraw electron density out of the ring or not. It's a meta-director. One position only, the meta position. So our product is going to be NO2 up here at the top, and bromine will come in at the meta position. Plus the hydrogen that was knocked off of the ring and the remaining bromine from Br2. So directors,